to Online Maths Hub. Today we have this question to solve right in front of us. Of course, you can see that clearly. They say that if alpha and beta are the roots of this quadratic equation you are seeing right here, find alpha cube plus beta cube. That is the I question. And then we should also find alpha divided by beta cube plus beta divided by alpha squared. And then I, which is number 3, is saying we should evaluate alpha squared divided by beta plus beta squared divided by alpha. We are going to be solving it, and then it's just pretty simple. We are going to be doing it together. But just before we continue, like we've always done, if you are new to our class, ensure you give the video a thumb up, subscribe to our channel, and also turn on the notification icon so that whenever we release new content, you will actually get to know more about it. Okay, so having said that, we're just going to delve right into the problem and we start solving it. Okay, so I write my solution. Okay, now writing my question, the quadratic equation, we are evaluating the root. We are using the root to actually evaluate these questions is 3x squared minus 4x minus 7 equal to 0. Okay, so question number I said we should evaluate alpha cube plus beta cube. Okay, now there are a couple of things I will need to remind you guys even as we solve this, so that it will actually help us in solving this. First, if we have a quadratic equation in this general form, ax squared plus bx plus c is equal to 0, and if alpha and beta are the root of this quadratic equation, you remember that the sum of the roots alpha and beta is defined as minus b over a, and then the product of the root alpha times beta is also defined as c over a. So this is the idea we're actually going to be using to solve this, and good thing they have actually told us that alpha and beta are the root of this equation. So in getting our alpha and beta, we just need to evaluate this. Okay, so the sum of this root, the sum of alpha plus beta is equal to, so we have minus b divided by a. So in this case, this is our a, this is our b, and then this is our c. So we have minus minus 4 over 3. Okay, and this is actually going to give us 4 over 3. Okay, because minus multiplied by minus is actually going to give us plus. And then the product of the roots, so let me just clean here so that it wouldn't be confusing. Okay, now the product of the roots alpha times beta is also defined as c over a, which is minus 7 over 3. Now this is what we've gotten, and then all we are just going to be doing is we want to express alpha cube plus beta cube to be in form of alpha plus beta and also alpha times beta. So we're going to express this so that the combinations will just be the sum of the root and also the product of the root. So that's what we're going to be doing. Now I need to also remind you that alpha cube plus beta cube, we can actually write this to be alpha plus beta, okay, bracket and into bracket alpha squared minus alpha beta plus beta squared. And so if you expand this bracket, it is actually going to give you this. Don't forget, we just want to express this in form of alpha plus beta and also alpha times beta, so that we can just substitute these values we have here and then we get our answer. So since we've gotten this alpha plus beta and then alpha times beta, the next thing we want to evaluate is alpha squared plus beta squared. And then we also know that, let me just write this. Okay, so picking it from here, this is also equal to, we can write this as alpha plus beta into alpha squared plus beta squared minus I'm just writing this alpha times beta. So I want to change this. Don't forget, this is also having squared over here. So alpha plus beta. So if I put this in bracket, okay, now I can write this one to be in form of alpha plus beta squared minus 2 alpha times beta, and then I put the other one minus alpha times beta. And so if you expand this, you're actually going to have this. Okay, now you can see clearly that we've gotten this alpha cube plus beta cube in form of alpha plus beta, and also alpha times beta. So if you simplify further, you're going to be seeing that this is going to give us alpha plus beta, okay, into alpha plus beta squared minus this is actually going to give us minus alpha 3 alpha beta. Okay, so what we are just going to be doing now is just to substitute these values that we've got right here. So substituting this alpha plus beta, we had it here to be equal to 4 over 3 into alpha plus beta 4 over 3, and then this one is squared minus 3 into alpha multiplied by beta is actually minus 7 over 3. Okay, so simplifying further, what we are going to be having is equal to 4 over 3 into 16 minus 9 plus minus times minus is actually going to give us plus. So if you multiply it, you have 21 over 3. Okay, so this is what we've got, and then if you simplify this further, you should be having 4 over 3 into of course this is 9, and then if you simplify this, it should give us 79, okay, over 9. Okay, and then of course if you simplify this further, you should be having 316 over 27. So we've gotten that our alpha cube plus beta cube is equal to 316 over 27. So the next thing I want to move on to solve is actually the B part of it, that is the II part of it, which basically says we should evaluate alpha divided by beta squared plus beta divided by alpha squared. So that's what we have, and then we can just use the same way we simplify this. So we just want to make this to be in combinations of alpha plus beta and also alpha multiplied by beta. So if you want to find the LCM here, alpha beta all squared is actually the LCM. So if you simplify this, you are going to be having alpha cube plus beta cube. Okay, but we've actually gotten alpha cube plus beta cube in question number 1. So this one seems a lot simpler. So we'll just write this 316 over 27, and then divided by alpha times beta is actually minus 7 over 3. But in this case, it is having a square, so we'll put it right there. So if you evaluate this further, you'll be having 316 over 27 times 9 over 49. Okay, so that's what we have there, and of course you can simplify that further to have your answer. Of course 9 can divide itself here 1, and then you can also divide here to have 3. Okay, so if you simplify that, you'll be having that your final answer is 316 divided by 147. So it's pretty simple. Now I'm going to clean here so that I can solve the III part of the question. Okay, so solving the III, we have the question is alpha squared plus beta plus alpha squared divided by beta plus beta squared divided by alpha. Okay, so we still find the LCM. This is alpha times beta. So if you simplify, you'll be having alpha. Okay, so we'll be having alpha cube plus beta cube. Okay, and then similarly, we have also gotten our alpha cube plus beta cube. So we just replace it here. Okay, 316 over 27, and then divided by alpha times beta, like we saw, is minus 7 over 3. Okay, and then simplifying further, you're going to be having 316 divided by 27, okay, times 3 over 7. Okay, of course the minus is still there, don't forget. So this 3 can divide itself, and then if it divides 27, you have 9 right here. So simplifying further, you have that your final answer is 316 divided by 9 times 7 is actually going to give us 63. And that's how you can actually solve this. So each time you have a problem like this, you've been given the roots and you are asked to simplify stuff like this, you can be able to use the same ideology. Just find a way to simplify the expression you've been asked to evaluate in form of alpha plus beta and also alpha times beta. That way you can be able to make your substitutions and then get your answers. And so I hope you've understood it. And of course, if you also have any question, if you encounter any challenge, do well to drop your question in the comment section, and I'm also going to get back to you. And if you have enjoyed the video, do well to give this video a like, and then subscribe to our channel for more updates. Turn on the notification icon so that you always get notified each time we release new content. And I'm going to see you guys in my next video. Bye.